I'm going to start simple with counting.
Counting. It
Yes.
should be a very easy one. Surely everyone with some SQL experience can do a simple count. How can it go wrong? Hello and welcome to Tech Yak. My name is Andreas Lengkeek, a software architect here at SSW, and today I'm joined by JK. He's a solution architect at SSW, and he's been through the trenches of entity framework and database performance, and he's here to tell us everything he's learned and some of the questions that we might encounter ourselves. JK, welcome to the show.
Hi, Andreas. Thank you for having me. I really enjoyed the last show for the logging, and I'm really happy to be back with something new.
That's right, we're here for part two.
Yes, and this time around, all of the experiences that I got from when jumping from client into client and looking at my friends' code, looking how they use EF Core, develop a little bit of PTSD seeing some codes, and I want to show people basically how to avoid common issues. And when they were wondering, should I use as node tracking or should I use first of the fall to list, show you a little bit of consequences, a little bit of what happens if you don't do the right thing in EF Core and how you can fix it.
Fantastic, let's get to it.
All right, so here I have Visual Studio, but first I want to show you the data structure. So over here I have SalesDB. It's a open source. We're going to put a link to it. And the most important part of this is the sales table has 6 million records, which is, a nice representation of what happens when you make a mistake on a scale. So, usually it's like how you can scale things, and I'm now going to show how things can go wrong on scale and also how to fix them. And next part up is it's all the code that I'm going to show you is already on GitHub with all of the metrics that I have recorded so far. And what I'm going to do is I'm going to show you some code. Then I'm going to run it in Postman so we get a feel for performance. But I already done some load test on the functions, on the endpoints already. So we can basically see how well it would perform in 60 minutes if you're trying to use 5 concurrent requests.
It seems like a really good sample database. I mean, 6 million records, it's a medium-sized application, and we can start to see the impact of these kind of optimizations.
Correct. And I'm going to start simple with counting.
Counting.
Yes.
It should be a very easy one. Surely everyone with some SQL experience can do a simple count. How can it go wrong?
Well, yes, the famous words. How can it go wrong? So over here, what I have is the worst case scenario. I have here get base query because some of the machines actually can handle this. So I have to do a little bit of conditional. Hey, if it's on this machine, don't run the full database. But what I just do is I return the sales table as iQueryable, so I can query. And what I have seen in some of the code bases is to list. Don't worry about this one. This one just adds a little bit of context. I can show it sometimes later what it does. But over here, what we have is we're getting the sales table. We get everything out of that sales table, and then we count it. Now, if I run this, and hopefully I have not forgotten to close something.
Perfect. I think I can already sense that the number one thing with performances and databases is try not to do your big operations in memory. And here we're loading this massive table.
Correct. So what's going to happen is usually it takes about 20 to 30 seconds for this to load. Actually, I could do Postman over here. I'll do the next one just so because this is already running. And what happened here is it does download the whole database and then it does count, which obviously if you have 6 million, it's horrible. But some people don't notice that because you may have 100 records, even less than 100 records. In dev, it doesn't scale that much. So you end up with not enough data to be a performance issue until a year or two in. And here you can see, okay, doesn't show us currently the timings, but I can tell you this would be very horrible. If I go to the load tests over here, and I have here the worst case, what I have here is I ran a Bombardier, which is a tool where you can gently load test your queries, your endpoints. And over here, I have done the same thing as before, a worst case, done 5 connections concurrently for 60 seconds. So it only runs up to 5. And it tries to finish them as fast as possible. And it was only able to do 0.1 request per second.
Wow.
0.1 per second. So that is a very horrible performance. And
yeah, you don't want to be seeing that in your production database, just for a simple count. I mean, imagine the more complicated queries.
Yeah. Now, if you ever happen that you do need for some reason to get all of that, there's a nice trick you can do as node tracking. And as node tracking is going to automatically give you 30% performance on the query. So if I run this is going to, instead of doing 30 seconds, it's going to do 20 seconds. Now here it's not going to give you a nice result because we are using Teams, we're using lots of different things, and the CPU may be busy. Oh, okay, 8 seconds, that's actually better than I expected. That's what I wanted. And I also, the GitHub that I have created allows it to see what SQL actually generates. So here you can see that it does nothing special. It just tries to get everything. And over here, you can see that it's about 7 million actually records, and it takes about 8 seconds. So it's much better than 30 seconds than what I was testing for the worst case.
That's a pretty simple update there.
Yeah, very simple. And if you still, for some reason, need to return everything, you can even further improve it by doing select and just get, say, just ID or something like that.
So you're simplifying the columns you're getting. It's just simply you're returning less data from the database. It's less going over the wire.
At this stage, it's almost less of how to fix it and how to limit the damage. But what you can see here is we have 4.5 seconds, and the query is a little bit easier. Okay, I have made a bug over here, but don't worry about it. This is also needed to be here. But
I can see it's printing the SQL before it does the query on top. But the actual query that it's running actually does select the single sales ID column.
It would be just doing the single ID. And just to show you the difference, just to do that. Now, in this particular case, you don't want to do that, but it's a really nice self-contained example where you can see the impacts of, doing simple things. So here, just with node tracking, we got from 0.1 requests per second to 0.5 requests per second. And then when we did the ID only, we got 1.4 requests per second. It's almost usable. So yeah, you can see how much performance gain you can get with just a few things. But if we move to the best case, for instance, the best case is just do the query and just do .count. What that does, if we go here and we run it, it's now only 254 milliseconds.
Wow, compare that with the first one and the same result you're getting back. That's a lot of performance increases.
Yeah, in fact, this is right now slow. I managed to get it to 80 milliseconds. And what happens here is you can see that the average request per second now is almost 18, which is pretty good, considering that you have to count all of the cell. You need to count all of the rows. It's pretty complicated query. But another thing that you have to consider is when you run this, for instance, most of the work is on the SQL server. But when you run the queries above, where you have two lists and you have a lot of things to get from the SQL Server, you also need to consider there is a lot of work on the web application. It actually becomes a point where your SQL Server doesn't do a lot of work because your web application is so busy passing the data.
You want to make sure that those data operations are being kept to the database, and you don't want to be taking too much of that responsibility in the web app.
Yeah, and here in this case, we have 7 million records. Now you can imagine that if you have just 1 byte, 7 million, that is 7 megabytes. If it's an integer, that's multiplied by 4. And if you have, say, 50 requests over a small period of time, that's multiplied by 50. And you can start talking about in gigabytes that needs to be allocated in your memory. And if you don't use S-node tracking, that almost duplicates the amount of storage. And all of a sudden, your 32 gigabyte laptop cannot handle the load test.
Yeah, and you can see with this just simple example, you'd think most people would look at count and go, okay, let's just do a select count of your ID column, and they wouldn't have this problem. But I guess this really shows you the simple increases in performance you can get, and by using what Entity Framework provides.
Correct. And now I have done some examples that you can play around, how you can do in raw SQL. I'm not going to go too much into detail. You can actually run raw SQL. But what I found is, at least for the counting, the performance is the same. So either you go with the APIs from SQL Raw, or if you're trying to go a little bit more old school and you're trying to run more like SQL commands, the performance is negligible. So if you're looking for improving that kind of performance, you're probably wasting your time. But it's not that this is not useful, but it's not useful if you're just getting one integer.
So this is a pretty simple example. Is there a way we can ramp this up, or a more realistic one where we can see this performance hitting even earlier, these other joins and stuff like that?
Yeah, so I have prepared some join examples as well. So here I have a worst case scenario, not really worst case. With joins, what I have seen, they're truly, truly horrendous things. But here is one of the bad examples that I managed to find.
I mean, this looks not too bad. I mean, I'd use this in a regular database. We're using the .include method. What's wrong with this?
Yes, so what is happening here? Let's see what we're actually trying to achieve. Is we're trying to return a sales with a salesperson, and we have a couple of things over here. Now, what happens sometimes is we either have say this line of code over here, we're trying to get some data from the database, and we might package this into a method. Or what happens is that the mapping logic change over time. And in this particular case, if I go to Postman, what we're going to see, not pagination, join, what we're going to see is that it takes very long time. And the reason for this is we are actually trying to get all of the products, all of the customers, and all of the salesperson within this condition. But if we look down here, when we're doing the mapping, we're only using salesperson, but the EF code doesn't know that that's the only thing that we need, because we already got all of the data from the database. So there's no way for EF code to optimize this query. So what happens is, if we look into visualize over here, we can see that it selects everything. It joins all of the tables and then does the where clause. So it tries to get everything. And you can see here the performance is 6 seconds, which is pretty terrible. Let me see if I can get the join. Worst case. Okay. So you can see that it's we got like 0.8 requests per second. And if we go for the bad case, which we improve the situation a little bit, where we remove all of the includes that we don't need, If we go to the Postman and we run, so what we did right now is we manually clean up the includes that we don't need. You can see we got half the time as before, so it's 50% faster, just to remove the things that we don't need. And you can see here that the link query is also a little bit better.
It's a little cleaner.
Yes, and to avoid those issues, what you can do is what we call implicit join. So over here, what you can see is we are getting all of the data directly. We're getting the actual database entities from the database. And even though, keep in mind, we're using S-node tracking, which already gives us 30% additional performance already. So that would be even worse if you don't use that. But here you can see that we're doing mapping to specific class after we got all of the data. Now, if we're doing while this is happening, you can notice here that I'm not using include. I'm just saying, hey, this is all of the data that I need from the database. And what happens is if I do implicit join, is we might not get necessarily a better performance, although we do actually get, which is a nice bonus. But what's important is we end up with the optimum query. So here we might be getting a little bit better performance because we're not getting the whole salesperson table out. We're only getting a couple of the columns. And
so you can actually join these tables without explicitly including them.
Correct. And when you're doing this, you're not only improving the performance in terms of if you remove something in the mapping, you're not actually including that table, you're not joining to that table. But when you're starting to have thousands of records, each column is going to add kilobytes or megabytes in transfer. And then that is going to add in also parsing and then assigning and all of that stuff. And it adds up when you're starting to scale up, when you're needing to get more and more data. So this is where we're getting a bit more performance. Even though technically it's the same thing, it still is more efficient. Now, another thing that you can do is a split query. Now, this is an interesting thing because I won't show you the results just for sake of time, but because we are using data directly from a specific table, when you use a split query, you would imagine that it could be able to split query and say that because we are only querying for one specific salesperson, you would imagine, okay, it's going to make a query to just get that one salesperson and then assign it afterwards. But it doesn't happen that way because there's a limitation of split query where if you have one-on-one relationship, it will not split the query. But what you can do, if you want to do a little bit of optimization and also a warning regarding premature optimization, is you can actually get the salesperson separately, and then you can try to add it in the query over here. So what happens in this case is, and the reason why we're doing this is, we're constantly getting the same salesperson in the same query, which is kind of a waste. We know that it's the same, so we can get it once. So why don't we do it in such a way that we're just saying, okay, this is the person, let's just prefetch it. What happens is if you do this way, is that it will actually include the string to the query, and then that's going to be executed on SQL Server. And then it's going to include into every single row, which is going to make it larger. And then it's going to be more stuff for you to download from SQL Server, more stuff to parse. And then this query, in fact, is takes about, I think, 300 milliseconds longer than it should. But if you do the same thing, like we did before, and we're separately assigning the salesperson. So we're not doing it in the mapping. What happens for this one? And all of the results are in the GitHub. So if you're interested in details, you can look up for that. You can see all of the timings. This is in my testing, sometimes even twice as fast as the original queries. Now here on my desktop, on my laptop, it's very janky. But on my desktop, which has a more consistent performance, I had a much better results. So for instance, we kind of forgot to look at the load test data, but here we have about 4 requests per second. When we did the implicit join, when we did split query, we had, it's roughly the same performance. When we did manual bat, that's the one that we did the projection. We almost lost a full request per second. And when we did fully manual, where we separately done mapping at the end, we got 7 requests per second, which almost doubles the amount of performance. And if you look about the code, it's not really that difficult. We just get the one person separately, and then we update the list separately at the end, all in memory. So this is kind of for simple joins. There's a little bit more complicated things going on here. Now, I'm not going to go too much into details, but what's happening is we're trying to select from multiple different tables. So over here, what we have is employer stats. So we want to get how many sales we have and all of that stuff. We want to get what's the first name, last name, how much sales they got. And then in the end, we want to get a list of all of their sales. And here is a hidden another join, which is the product name. And over here, you can see that it is 2 implicit joins. So what happens here is if we would run this one, complex, we would get a certain performance, but you can improve this by simply adding as split. So in this case, it would help. There is only one issue with this one. When you use as split, is that the as split does not allow a select inside a select. So you would need to process this separately.
But some people might not know that Entity Framework actually provides this as split functionality, where if you're doing these joins, Entity Framework can try and handle that for you.
Yeah, so by default is as single query. But you can say, hey, I want to split this up. And things that are many to many, it's going to split up the queries into multiple ones. So for instance, if I go and quickly run the complex, we have here, you can see we have a couple of joins. It's pretty decently sized SQL. We have 2 seconds execution. And here we have with the split query, sorry. And what we can see is slightly easier query. You can see that this is much simpler made. We do have a warning over here, but it should be fine. It just means that not everything was able to be split. And also you can see, okay, here we cannot see the performance, but if I go to the complex join, so we can see the complex join is 0.16 requests per second. And then with the split queries over here, it's 1.74 requests per second. So if you have a very complicated query, you can sometimes get away by just adding .split and just modify a little bit the query. And if you go a little bit further, you can do manual splitting up of the queries, and you can get even better performance.
I think what's surprising to me here is that you can actually get more performance by doing more queries instead of putting everything in one.
Correct. Yeah, and I'll just show you the code for the manual split, you can see here that what I'm doing is I'm getting information for the employee separately. And then once I have that, I'm saying, get me all of the sales for that person. And the interesting thing, what I do is I'm saying, once I have all of the sales, get me all of the product IDs in memory, distinct them. So we have only distinct product IDs. And then I use it in a new query, products, where I'm trying to filter them. Now here, there's a caveat. There is a diminishing return. So if this list returns too many unique products, this is going to become a performance bottleneck. So you will need to understand your data, because this particular code over here, products contains, is at the same time a very, very good way of optimizing your queries, as well as very, very good way of destroying your SQL Server at the same time. It's all about how many IDs you get in. So that's one of the warnings I would put over here. And this is right now what I have for the joins. But one of the last thing that I want to leave with you, but I'm actually preparing a full talk about this, because this is a massive topic and I have seen a lot of things. And this is one thing that has been consistently done incorrectly, is basically pagination. So here I have a worst case scenario. And what I see in practice is, because people don't know how to get a count for pagination as well as filtering it. So what they do is they're actually getting all of the data from the database, which is a horrible way to do it.
So it's a horrible way to do it, but I know sometimes I filter in memory. You know, how bad is it really?
So if it's a fixed table where you have a certain amount of data that's going to be there and that's it, that it's okay. Like for instance, you have user roles, sometimes even user table, when you know that you're not going to have more than say 1,000 active users. It's not great, but it's not going to destroy your database per se. But for instance, in this particular case, when I was testing this code, I was doing against a sales page. And imagine that somebody implemented that very early on. Then they cannot afford developers anymore. This basically was going on for years. For years, they were accumulating data, and for years, the page was getting slower and slower. In this case, we have only 2 requests per second for this particular case. But you can fix this. And this is actually also a query that limits quite a bit. It's just one salesperson. Imagine if you have a much wider query. And here you can also, here you can see that I'm filtering over here after I get the list. But a more optimized way to do this is you write the whole query over here. So I'm trying to do where clause. I want to do selecting. And what I do then is I'm saying, okay, for this query, this iQueryable, give me back count. So it's going to execute this query. But the interesting thing is it's actually going to ignore this select statement. And it's also going to ignore anything that is not relevant to get the count. And this is actually very fast operation, all things considered. And then the next line, what I'm doing is I'm saying, okay, now update the current query to skip the amount of results that I need and take the size of the page. And now this is going to be highly performant. So if we go to how fast it would be. It's now 28 requests per second. So we've gone from 2 requests to 28.
And that's quite a mind-blowing performance improvement, like just with these
Yes.
small changes. Yeah.
Yeah, so you can see here we've done some small changes and we gone like 10 times better performance. There's some cases that I have found 100 times performance. There's a lot of cases where they done for each loops, and in each for each loop they done request instead of consolidating what IDs they want to get and prefetch them. And there's a lot of cases where you can really optimize things. But one thing to keep in mind is like there's a balance between optimizing and just making it work. But there's a saying that you shouldn't be prematurely optimizing. But there's also a danger with just saying, okay, it just works, because just works can destroy a database with a little bit of scale. So you should really think about what is the best performance I can do for code readability as well as performance. I don't want to spend half an hour or an hour to make this, but if it takes me only 5 minutes, you probably should do it.
Yeah, it's an important consideration whenever you're dealing with a database to have in the back of your mind.
Correct. One interesting issue that I have found is people were puzzled how you can do filtering in EF Core if you have different wait clauses, for instance. And what they do is either they do very, very funky logic where they say if it's this and that, or I have seen a case where they did sales and they did a complicated thing where they did where X, say salesperson ID. Actually, first, salesperson ID is not null because this is nullable, and my machine froze. And this, and then they put this into brackets, and then they started to stack these statements, or I think it was or. And then outside it was and then they started to stack all of this for all of the queries, and that makes it really, really badly readable. Once you have, say here we have 1, 2, 3 3 different parameters, and you can imagine in more complicated filters you have even more, and these are actually being sent to SQL Server, and SQL Server has to pass all of that and filter based on those rules. But the better way is you can just do a iQueryable over here, and you can just say, hey, if I have value, add this condition. If I have that value, do this condition. And they are basically string as AND operations. So this would be the same if I have all 3 values. This would be the same if I do AND this and that. If you need to have an OR operation, there is a way, but I don't want to go into this because it would be too much.
But and for that, people can check out your blog or your talk.
Yes, I'm working really hard on getting that done. And just to blow everyone's mind as the last thing to show you, any operation is a very interesting thing. Like obviously, if you do to list and then you do any after you get all the data, that is terrible performance. But what I was genuinely surprised is if you do first of default, so you get only one item, and compare it for the same query doing just .any. This is slightly faster. So what that means is if you want to check if a record exists in the database and then get it, it is always better to just get it right away. Although in this case, the column size is small. It might not be quite true for larger tables, for larger columns, but in this case, I was doing query against sales table, which is 7 million rows, pretty big. And yes, this was slightly faster, which I was genuinely shocked.
Yeah. I think what this shows is that really for anyone, if you're looking at database optimization, there are so many small steps. You can just see by the sheer volume of examples you have here, where somebody can apply tiny optimizations. And the more experienced you get, the more you can place them kind of as you're developing the code for the first time. But these small things that you don't do, you might do subconsciously, can add up and cause like a really unperformant database, and having a review and adding these small optimizations, having an understanding of your data can really have an impact, and it becomes so important to the end user.
Correct. And if you're interested in all of the performance things, I haven't gone through all of them just for sake of time, but all of these images here that gives you the load test are all on GitHub. I think it's over here. It's over here on this GitHub. We're going to show you the URL. At the moment, it's on the Blazor application www.root images. And the reason for this is I'm going to make the Blazor as the entry point where you can test out things and have a bit more explanations like I had right now. And if you want to actually replicate all of the tests that I have done, there's actually a PowerShell script in the API project where it shows you roughly how I did. So this, you just copy this part over here and change the endpoints, and you'll be able to do the same test that I did on my machine. And my machine was pretty decent. It was Ryzen 5, what was it, 2500X. So pretty decent machine, 32 gigabytes of RAM. And this is what I used to test it out.
Yeah, fantastic. So if people want to check out your results, they can have a look at this GitHub repository. They should definitely go and check out your blog and follow you on Twitter for all of the latest in database and many more adventures that you go on. I know you speak on a bunch of different topics. I just want to say thank you for your time, Jernej. You've really been enlightening to me.
Thank you for having me.
And we'll see you next time.